In this video, we're going to talk about factoring quadratic expressions that are in standard form when a is equal to 1. That's the learning goal, is just your title, and I think you should remind yourself what standard form looks like. So that's y equals ax squared plus bx plus c, right? You just might want to have that on your page somewhere. So when we're factoring quadratic expressions, there's some different rules that apply and also some different steps that we take. So I'm going to take you through how I tackle factoring quadratic expressions. So let's start with an example. Let's say I have x squared plus 7x plus 12. Okay, I see right away that it's in standard form. So I'm not going to use any of the strategies that I used in the previous videos. I'm going to focus on the strategies that I need to use when factoring a quadratic expression in this form. The reason we say a is equal to 1, if you saw in the title, it's because technically there's a 1 value here, right? And when we write standard form, it's ax squared plus bx plus c. So we're just working with a is equal to 1, which means there's just a 1 here. In future videos, we're going to work with things where there's an actual value here. Okay, so the rule with this is I'm going to have to find, in order to factor this, two numbers that when I multiply them, are going to give me 12, and then when I add them are going to give me 7. So I need to find, if you want to write it over here, I have to find two numbers that when I add them equal to b, and those same two numbers that when I multiply them equal to c. So let me show you how I set up my little chart here. I'm going to rewrite this. Okay, so I know that I'm going to have to find two numbers that multiply to 12. So I'm going to set up a column where I can write my factors of 12. Right? Now I know that my product, right, that means when I'm multiplying, is going to have to be positive 12, but when I'm adding it, my sum is going to have to equal positive 7. Okay, so this is the B, this is C, and this is B here, right? The reason I put the positives in circles there is because it's important to pay attention to the signs, especially when negatives come into play. This case, we're working with two positive signs, so I know that both my numbers have to be positive. So what I'm going to do is think of my factors of 12. So what times what equals 12? That's what that means. So I like to start with 1 and then progress in numerical order. So I know 1 times 12, that's going to give me 12, right? Every single one of my products, I know when I multiply, is going to give me 12. But what I'm trying to do is I'm trying to find which two of those factors, when I add them, equals 7. Okay? So 1 times 12 is 12. What's 1 plus 12? 13. Does that equal 7? Nope. Let's keep going. How else can I get to 12? I can do 2 times 6. 2 times 6 is 12, but when I add 2 and 6, I get 8. It's wrong. What's next? Numerically, we did 1, we did 2. Can we use 3? 3 times what? 3 times 4. That's going to equal 12, and when I add that, that equals 7. Winner, winner, chicken dinner. Now I know what I'm going to work with. So what you're going to do is you're going to set up your brackets over here. And I know that inside my brackets, I'm going to have x and x, right? Because if I were to expand it, I would get x squared. We already determined that we know we're working with positive numbers only. And the factors that I discovered were 3 and 4, right? And if you're not sure this is correct, you can go ahead and use the distributive property. So x times x equals x squared. X times 4 is 4x. 3 times x is 3x. And 3 times 4 is 12. If I simplify it, I get x squared plus 7x plus 12. Okay, so that is how we factor a quadratic expression when a is equal to 1. Let's do some more examples. All right, let's say I have x squared minus 29 plus 28. So now we're working with some different symbols here. Okay, so I know that I have to think of a number that when I multiply it, I think of two numbers that I multiply it that are going to give me 28. So I'm going to need factors of 28 for this. All right, so that means when I multiply these two numbers, my product is going to be positive 28. But when I add these two numbers, their sum is going to give me negative 29. Now it's important, again, to take notes of the symbols here, because when I have a product that is positive and a sum that is negative, both of the numbers inside my brackets at the end are going to have to be negative when it's factored. Okay? Try to make this a little bit smaller here. There we go. So let's go ahead and begin our process by finding the factors of 28. So remember, both the numbers have to be negative. So I'm going to work with negative 1 times negative 28. A negative times a negative is going to give me that positive product. And then negative 1 plus negative 28 is going to give me negative 29. Well, that was easy. My first set of factors are what I'm working with. So I can go ahead and plug them in to my sets of brackets in order to factor this quadratic expression. Let's keep using this page since we have so much room. Just make some space here, get rid of this chart. Let's try one where we have x squared, say plus 3x minus 18. All right, so I'm going to need to think of two numbers that when I multiply them, give me c, the c value, which is 18, and when I add them, give me the b value, which is 3. Okay, so I'm going to need factors of 18. Okay, so my product has to do with multiplying, right? My product should equal negative 18 when multiplied, and my sum should equal positive 3. Okay, so now I have a negative product. So when I have a negative product and a positive sum, that means that when I am working with the terms inside my brackets, I know that they're going to have to be one of them negative and one of them positive. Okay, so it's either going to be negative and positive or positive and negative inside my brackets. So let's go through the factors. And what we're going to do is we're going to flip-flop the factors between positive and negative. So I'll show you what I mean by that. I'm going to start with 1 because I always start with 1. So let's say I have 1 times, that's my positive, and I'm going to need a negative, so I'm going to do negative 18. 1 times negative 18 is going to give me negative 18, but when I add it, it's going to give me negative 17. It's not what I'm looking for. Okay, I'm going to flip it. I'll do negative 1 times 18 instead. I still get negative 18 here, but instead I get positive 17 when I add them. That's not what I'm looking for. Remember, this is always going to be negative 18, right? Okay, so let's go to 2. I'm going to do 2 times what? 2 times negative 9. That's going to give me negative 18. And if I do 2 plus negative 9, well, that's going to give me negative 7. That's not what I'm looking for. Let's keep going. Do negative 2 times 9. When I multiply that, I get negative 18. But when I add it, I get 7. All right, no luck. If you can see the pattern with flipping the negatives in between the factors and you know it's not going to work for you, you don't have to write them all out. I'm just doing it to show you all the steps. Okay? Let's keep going. What's another factor of 18? Is 3 a factor of 18? 3 times what? 3 times negative 6. That would give me negative 18. And if I add those, I'm going to get negative 3. That's not what I'm looking for. What if I did negative 3 times 6? Well, that's going to give me negative 18. And if I do negative 3 plus 6, that's going to give me 3. So here I have just found, oops, let me get my color. Right? My two factors that I know I need to work with. And you know, remember how I said it could be negative, positive, or positive, negative, depending? Well, now we can see here it's negative and a positive. So I know I have x, and it's going to be a negative 3, and then an x plus 6 for us to have factored it. And you can always check by expanding. Let's do one more example here. So we've got x squared minus 4x minus 21. Okay, so now we're working with two negative symbols in our quadratic expression. The first one we did was positive, positive. So obviously we're using numbers that were positive. The second one we were doing was negative, positive. Right? We did positive and positive. So my numbers, they had to be positive. The second one we did was when I should write this here, the product and the sum. Second one we did was when the product was positive but the sum was negative. And that meant that both my numbers had to be negative. The third one that we just did was when the product was negative, but the sum was positive, and it kind of went either way. I knew that I needed a combination of both numbers. I knew that I was either going to be a positive and a negative number, or a negative and a positive number. And now on this last one, my product is negative and my sum is negative. So what does that mean? That means that I'm going to have the same thing as number 3. Which means I'm going to need a positive number and a negative number, or a negative number and a positive number. One of those two combinations, okay? You can write this down in your notes if you find it helpful for you. All right, so let's continue with the question that we're working on. So I need to find two numbers that when I add them are going to give me 4, but when I multiply them are going to give me So they're going to give me negative 4. When I multiply them, are going to give me negative 21. So let's set up our table. I'm going to need to find some factors of 21. We're always finding the factors of the number that we're multiplying to get to. So my product is going to be negative 21, right? And my sum is going to be negative 4. Okay, so I'm going to need a combination of positive and negative numbers, or negative and positive numbers. So that means it's going to be either like this, x plus something, x minus something, or it's going to be x minus something, x plus something. So let's get started with our table. Factors of 21. Well, I always start with 1. 1, that's my positive number. I'm going to do times negative 21. That's going to give me negative 21. When I add that, that's going to give me negative 20. No dice. Okay, let's do negative 1 instead. Negative 1 times 21. Still gives me negative 21. When I add it, it gives me 20. No good. Okay, can I use 2? No, because nothing times 2 equals 21. Can I use 3? Yes. I can do 3 times negative 7. That's going to give me negative 21. And when I add that, it's going to give me 4. Lovely. That one wasn't too long at all. Okay, so I found my factors here, and I can see that I'm working with a positive 3 and a negative 7. So I know that I can just insert that right here. Oh, I don't think it came up. Okay, there we go. Of course, my iPad stops working in the last seconds of the video. Okay, so I just inserted this right up here. And that's how we factor quadratic expressions when the a value is equal to 1.